the use of heavy masonry material, this is not mock stucco or mock adobe or hollow core concrete, this is solid material, can buy you 8 hours of slowdown of the heat during the day that can be offset at night. One of my favorite examples for students is to take the Sagrada Familia, Gaudi's church, because that's a huge volume church in a hot desert-like climate. And they let nighttime cooling, so they run air right through the heart of the church, up, out through the openings at the top. And there's a lot of exposed concrete that Gaudi actually articulated. It's not just polished round columns. These are explosive columns that increase the surface area of the concrete. So when the night air flows across all that surface area, it gets pre-cooled. So the following day, when the openings are closed down, you have a cool mass inside the building that can absorb thousands of visitors, which is truly impressive because you couldn't afford to air condition that building. You need a strategy.
Before we go into the podcast, if you could just go and rate this show on whichever platform you're listening to it, it makes a huge difference to the podcast, the amazing conversations we get to have, and the incredible guests we're able to get on the podcast. So it's probably not something you would think about, but if you could just go rate the show, follow it, or share an episode, it does make a huge difference to the show. Thank you so much. In a world increasingly facing the challenges of climate change, with the Building Green podcast, we will dive deep into the intersection of architecture, design, urbanism, and environmental responsibility. I'm Ladina Schipp, your host. I've been an architect and building site manager for the past 10 years. During my studies at ETH in Switzerland, as well as in my working environment, I've had many touchpoints with sustainability, like many of you, I guess. I've also learned to question what I've been told, which is why I decided to go deeper into the topic and uncover what sustainability actually means. My mission is to highlight the transformative power of sustainable architecture, not just as a practice, but as a catalyst for broader societal change. Subscribe for more of our content and enjoy the show. Vivian Loftness' career began during the first energy crisis in 1973. Leading her to research passive solar design and climate-adaptive architecture. As a university professor and a leader in organizations like the US Green Building Council and the International Living Future Institute, she has pushed for buildings that rely less on mechanical systems. She developed the concept of environmental surfing, a strategy that maximizes natural ventilation and daylight before turning to artificial climate control. In this episode, Vivian explains why modern buildings have become overly sealed and dependent on mechanical systems, how architects can design for location-specific climates, and why daylight and operable windows should be standard. She also shares her favorite sustainable project, a Singapore hospital that cut mechanical cooling by 2/3 using natural ventilation and rooftop gardens that feed patients. Thank you, Vivian, for joining me today. Your background is remarkable, 50 years of experience in sustainability in architecture. Can you tell me a bit about your story and what brought you to where you are today?
My story is probably very similar to a number of leaders in the sustainability world, which is that my college years was during the first energy crisis, where there was huge global concern about the end of oil and the need to transfer away from oil. And my master's thesis was already focused on the importance of architecture, really rethinking the way in which we're using energy and using as much natural energy as we could. When I finished my master's thesis, I had the great luxury of getting a Rotary scholarship to study in Finland. And I got to study a series of contemporary architects, including Alvar Aalto, who was still alive at the time, and Timo Pentila and Heikki and Kairo Siren. And I became fascinated with the fact that the Finns were so enamored with the craft of building, with the detailing of architecture being even more important than the sort of the shape and drape of buildings that so many architects today focus on. They really celebrated daylight and they celebrated sunshine, and you could see it in their architecture. So it set a lifelong interest for me in how we design for climate. I then had the opportunity when I returned to Washington to work for the American Institute of Architects Research Corporation to do collaborative work with the National Climate Center in the U.S., which is the repository for U.S. weather data. And as most people know, U.S. is huge and has dramatically diverse climates. I mean, there are 17 climate zones in California alone. So the ability to design for climate means that you really have to be a student of climate data. And so I became fascinated with how we design buildings very unique to location.
What were your biggest learnings there?
I think first place, indigenous and historic architecture that predates central air conditioning, in many cases predates electric lighting, in some cases predates central heating. I mean, obviously they had fireplaces and wood stoves, but not a central heating system. Many of those buildings were far more suited to the locations, and we lost our ability to make unique architecture for specific climate differences and started to generate homogeneous buildings that you couldn't even tell which city they were in. They were so similar to each other, and both in the residential and commercial sector.
I soon want to talk about your most important topic. You give a lot of talks about environmental surfing, but before we go into that, you've had a lot of different roles in advocacy and education, one of them with U.S. Green Building Council. What does your current role look like, and how does it contribute to advancing sustainability?
I've had the privilege of serving on a number of national boards, and each of them, I do fundamentally believe that architects need to be advocates in addition to being designers and educators and researchers. The U.S. Green Building Council's LEED standard emerged out of the brain trust of a whole host of players, both in the architectural field and the engineering field. And when they first launched LEED version 1, it had a slow rise in adoption among the design community. But by the time they got into LEED version 3, it became a mainstream standard for certifying buildings, and clients were asking the architects and the engineers to essentially deliver far more environmentally sensitive buildings without cost differentials. And it really triggered the education of architects and engineers and contractors and material manufacturers and system manufacturers, who essentially said, if we want to have these large commercial contracts, both from the federal and from the private sector, we need to be environmentally more sensitive. So it was absolutely the trigger. Going to the green building conferences every year, starting in Austin and every year since then, was the best education you could get on high performance buildings. It was the best environment for actually seeing products that were being created by industries. It was their cutting edge products because they now had an audience, not just for their mainstream and least cost products, but for their cutting edge high performance products. And so it was the best education you could get. It is a mainstream system. It's not trying to push the very ultimate goal, which is a net zero building and a net zero water, net zero energy, net zero land. I mean, that is the ultimate goal, is to make buildings that are actually regenerative and have no load on the environment in which they sit. And I have, most recently, I've joined the board of the International Living Futures Institute, which is the Living Building Challenge, which actually has no prerequisites. It is all required. So it basically says your building better be net zero. You have to reduce the loads to a level that you can meet it on site or in the adjacent sites. So you have to meet your water load, your energy load, and you have to ensure that you are not using new land, and you have to dramatically reduce your material loading, because we've been extracting far too many materials too quickly. The earth can't regenerate. And so the architects are beginning to really focus on how do we create sort of cradle to cradle material designs. So it's been a privilege to serve on these types of national and international standards.
That's nice. So talking about, we're already getting into the topic, I guess, of environmental surfing. For someone hearing this concept for the first time, how would you explain it in simple terms?
So I originally called the concept, to free roll your buildings, to essentially try to run your buildings without mechanical assist for as many hours and days as the environment would support. It actually has some meaning at Carnegie Mellon where I teach, because we actually have a unique annual competition called the Buggy Competition, where students free roll these very, very small streamlined buggies, which have a tiny person inside steering them up and down hills, and they race with speed. So free rolling just sort of made a lot of sense within the context of my university. It didn't make a lot of sense on a national and international. So I tried to think about what is the word that not only would inspire, but would give people a sense of joy around doing things in a unique way. And so surfing, of course, is just one of those things everyone immediately associates with being on the beach, wonderful water, incredible mastery of nature and human nature interfaces that are just fabulous. The key to environmental surfing is that, again, we're still trying to run the buildings with natural, renewable energy sources for as many hours and as many days as possible. But every climate and every culture has a different suite of renewables. So if we just start with a cold climate, like the ones in Zurich or in Pittsburgh, where you have predominantly heating dominated days, your largest energy load is often for heating. Your second largest might be for lighting. And then you start to look at cooling. The question is, what do we environmentally surf? Well, the first thing we do is we reduce the demand. So we do deep energy conservation. We have incredibly high performance windows. We have very high performance enclosures. We're doing passive house airtightness. We're literally trying to reduce the demand so that the internal heat generation, which is a free energy, it's all the people and the equipment and the lights that are in the building that essentially can meet the load, the thermal heating load of the building. But the second thing we're doing when we get that under control is letting the sun shine in. And of course, the sun doesn't shine in Pittsburgh and in Zurich and other places. It doesn't shine every day. So we really have to begin to dynamically control when we let the sun in and what we store it in, what we absorb it in, what we store it in, and how we get it back. And, all kinds of direct gain and indirect gain and isolated gain, passive solar systems, which have been well established, really provide for free heat for buildings. And they distinguish the buildings in Pittsburgh and Zurich from the buildings in Singapore or in Dubai or in Atlanta, where there's a whole different suite of priorities and natural renewables.
But nowadays, many buildings are still designed as like sealed boxes, completely locking out nature. What do you think is the biggest challenge architects face when trying to incorporate natural ventilation and daylight into modern designs?
Right. Really good question. We design buildings to essentially lock nature out. We seal them. We make them airtight. We make them dark glass. We reduce the window area. We're basically saying nature is evil. Let's make a thermos bottle and figure out the most efficient mechanical heating, cooling, and lighting strategies, which is the antithesis. This is totally non-resilient. If you have power outages that go for days or even weeks, you essentially have to abandon those buildings because you're in a spaceship that has no energy source, no way to provide the heat, the cool, the light, the breathing air. So I think one of the key catalysts to change will be resiliency. It will be what Alex Wilson from the Building Green group has called passive survivability. How do we, in fact, create a resilient building where you can survive passively for days, weeks, for as long as possible, if in the event that the power goes out or the heating source goes out or the water source goes out. How do we, in fact, do passive survivability? So I think that's one issue, is using the catalyst of resiliency and survivability to reopen the building. The other barrier that we have to get over is I think the engineering world is generally pretty resistant to operable windows because they basically don't have the level of control that you would have with a mechanical system. And so you're finding that even if the client is willing to put in operable windows, the engineer says, oh, you don't want to do that. And many of the systems that we design, the most common mechanical system in the US and in most high rises around the world is a variable air volume system. And it's designed for energy efficiency and for delivering adequate air and thermal conditioning. But it is designed on the principle that the building will be sealed and that you're essentially filling the bubble. And that's how you guarantee that the air and the thermal conditioning gets to every corner, is you're creating this sealed bubble in the system. And we have to break away from that. And there are engineers, leaders around the world like Transolar and others who absolutely will not design a sealed building. And as engineers, they basically say, we're going to design a building that does not need a mechanical system to be turned on. But they will put in the mechanical system for those time periods when nature does not have the ability to meet those loads, including right now the wildfires in California, which would be a moment when you may not want nature in your building, right? If your building is still standing, you probably want a very highly filtered quality air system working for you. But these are not the norm in Southern California. These are the anomalies. And so I think leading engineers are both the barrier and the greatest opportunity for moving away from sealed dark glass buildings.
Could you walk me through like a design strategy or a few design elements like shading or night cooling or something like that you think every architect should use?
Yes. So let me talk maybe through, I'm going to talk, I mentioned already briefly the lighting strategies, the heating strategies. The cooling strategies begin with, again, an efficient envelope that has windows in the right orientation, where you would avoid east and west, which are very problematic low sun angles that give you excessive overheating. You would bias yourself to north or south, depending a little bit on what latitude you're at. And they're much more easy to shade. So if you're in the northern latitudes, you will find a simple overhang on the south and vertical fins on the north will cut out your summer suns, but still allow in your winter suns. So shading is an absolute precursor to low energy demands. Then meeting the air conditioning loads, there's a couple of things. One is you can do a time lag cooling. If you're in a dry climate where the temperatures swing between day and night, almost every desert climate will have a huge diurnal swing between nighttime temperatures being below the comfort zone and daytime temperatures being way above the comfort zone. The use of heavy masonry material, this is not mock stucco or mock adobe or, hollow core concrete. This is solid material, can buy you 8 hours of slowdown of the heat during the day that can be offset at night. You can use night ventilation. One of my favorite examples for students is to take the Sagrada Familia, Gaudi's church, because that's a huge volume church in a hot desert-like climate. And they let nighttime cooling. So they run air right through the heart of the church, out through the openings at the top. And there's a lot of exposed concrete that Gaudi actually articulated. It's not just polished round columns. These are explosive columns that increase the surface area of the concrete. So when the night air flows across all that surface area, it gets pre-cooled. So the following day, when the openings are closed down, you have a cool mass inside the building that can absorb thousands of visitors, which is truly impressive because you couldn't afford to air condition that building. You need a strategy. You can, in dry climates, you can use evaporative cooling. People would argue, well, gee, if we use water for air conditioning, aren't we in a desert? Aren't we causing a serious crisis? Not really, because you use water for air conditioning with conventional compressor cooling, refrigerant cooling, and you use it in a far greater quantity. So we actually can save water by using evaporative cooling, and that includes literally spraying atomizing water in places where people sit, right? So you can sit in a restaurant that is evaporatively cooled. You could sit outdoors in a restaurant that is evaporatively cooled in a desert climate. And there's some beautiful examples at Mecca where they have umbrellas that open up and they have atomized water to provide cooling, because people are often there in the worst, hottest time of the year. And it's really a crisis for outdoor health and comfort. So there are a lot of strategies. There's also earth cooling. The earth is, if you go, 3 meters down into the earth, you get the average annual temperature, not the outdoor temperature. And the average annual temperature for many of those climates is about 10 degrees Celsius or 50 Fahrenheit. Well, that's great cooling temperature. And one of my favorite projects is a series of buildings that Skanska built in Stockholm, where they essentially have geo-exchange, not geothermal heat pumps, but geo-exchange, where they have a closed water loop that goes into the earth, drops the temperature down to 10 Celsius, and then they use a radiant ceiling, which is increased in its area, so it provides greater surface area for cooling, and just very modest PV-run pumps, which could be very resilient. Even if the power was gone, you would have cooling in those buildings. Now, that works extremely well in Europe and Scandinavia, because the cooling loads are not extremely out of range. It'd be much harder to do that in the Middle East.
Those are really interesting strategies. You have spent decades advocating for operable windows and natural light in workspaces specifically, but it's still not guaranteed in many places. What do you think it will take to make this a standard feature?
Yeah, daylight is another piece of the environmental surfing equation that I think is really important. I actually think we're going to regress for a little bit. LEDs are so efficient compared to incandescents that we have been cutting our lighting loads down to, a tenth of where they were a decade ago. And we've also found that we can do so much more playful things with LEDs. So we've now increased, in some cases, the total, lighting power density of how much light, how many fixtures we're putting in, and how often they're on, and how much advertising we're doing. And so I with light, right, I feel we're going to regress for a little bit. The triggers for daylight are a couple of things. One is definitely, with daylight comes views, and there is a growing body of research that humans desperately need connection to nature, beginning with visual connections, and then moving on to other kinds of sensory connections. But getting the ability to look out, I can look straight out of my window right here and look into a park full of trees that have snow lightly sitting on the branches, and I can see the snow is falling. And those are things that time of day cues and reminders that my energy level needs to stay high. All those things are incredibly important to my productivity and my health. So views, it also connects us with community, and that's extremely important for keeping community vibrant. The one body of research that I think is going to probably sweep through Europe more quickly than it gets to the US is circadian light, and the importance. It took us this long to realize that it wasn't just daylight in view that matters. It was the particular spectral quality of daylight in the morning, which is quite blue, and in the afternoon, which is quite red, that actually triggers serotonin, which suppresses melatonin, and triggers melatonin, which allows us to fall asleep at night. And now that we know that our hormones are tied to spectral qualities of daylight, we have two choices. One is we should bring daylight into our buildings or spend more time outdoors, or we have to simulate daylight with our electric fixtures. And not that you can't simulate it, it's just that we don't really know what else is in the daylight that we're receiving that our human body needs. So I think the hormonal connections to nature and what it does to our health and our productivity, I think those are going to be a growing body of research that's going to push us to care a lot more about environmental surfing, and especially relative to daylight and view.
Do you know if it helps or if it's enough to kind of fake this daylight spectrum with the amount of kelvins? Or
it does. There is research that shows that if we actually put intense blue light, on people working away early in the morning, their energy levels will be higher, and their productivity at a number of tasks will be higher. And so yes, electric light can provide some of the characteristics of daylight. My argument to architects: why wouldn't we embrace daylight? Well, it saves us energy. It provides us with views, which are not going to get out of the electric light fixture. And it gives us all of those spectral characteristics that nature would have provided us.
What do you think what the reason is why architects are not implementing more daylight?
Some of it is definitely caused by concerns about cooling loads. And some of it is caused by the fact that architects often don't control the layers on the window. They may control the glass specification, but they don't control whether the interior will have a light reflecting blind or shade, or if the exterior will have a dynamic shade. And the need for dynamics is important to effective daylight and shade. And architects often don't have the budgets for dynamic facades. So they're basically looking at static solutions. And the static solution is, smaller windows, relatively darker glass choices, and electric lights, right? Which is not the best solution, but maybe the most affordable solution. So unless there was a client pull or a standard pull for more effective daylighting, which there is. I mean, there's certainly, LEED standards and WELL standards and a number of other international standards are certainly amplifying the importance of daylight autonomy.
Maybe it even starts already at the beginning of the design process, looking at the plot sizes that we have, the building dimensions, huge building dimensions where we cannot split the floor plan in a way that every room has daylight.
That's a really important point. I cannot stress how those actually, I fundamentally believe codes and standards should forbid any occupied space that's going to be occupied for more than a temporary, storage transition space must have access to windows in the outdoors. It really, America has very deep buildings. We will have floor plates that could be hundreds of feet deep from the core to the perimeter. And most of the people in those buildings, we also have basements that people occupy for their entire workday legally. People don't even know it was snowing today or that it was a sunny day. And they don't know it was night until they get outdoors because they've been, basically in a windowless space for their entire workday. Those things should not be allowed. Luckily, the unions in Europe have made it clear that no one should have to work in a windowless space. So there's a 7 meter to the window wall, maximum, that really helps to determine that people have adequate seated views from their work environment.
If you're enjoying the show, I have a small favor to ask that would mean the world to me. By rating and sharing the podcast, you're helping us grow and spreading our mission of making sustainability really desirable and cool to a wider audience. Besides of that, imagine impressing your colleagues with the latest insights on sustainable architecture. So make sure you follow the podcast and become the most informed in the room. Thank you so much for your support. What needs to change in the US policies to make buildings more sustainable?
We tend to rely more on voluntary policies than we do on mandatory policies. I do think the voluntary standards have really helped. I think the federal government has been a huge leader. And some of that has come by executive order. So a president can write, and many presidents have written executive orders that have said to all the occupants of federal buildings, we will protect your health by doing the following things. We will save the nation energy by doing the following things. And so they have essentially set thresholds and mandates, and building operators all across the country, federal building operators, are trying to meet those mandates. So voluntary standards and federal leadership at the moment. We do have some corporate leadership. We do have some university leadership. We've got a number of major universities that are really pushing to get to carbon neutral campuses, by 2030. In wonderful places like Stanford in San Francisco, one of the mildest climates in America, where you really could environmentally surf for 95% of the year. But it's a goal that it takes the president, the leadership of the university, to adopt. I know that Harvard's a major leader. Cornell, there are a number of universities that have really been pushing. So I don't know as clearly what's happening in Europe and Asia, but I certainly track what's going on in the U.S. to trigger super sustainable buildings.
Now, if we move away from the policies and the leaders towards the homeowners, you have talked about buildings or designing homes that expand and contract with the seasons. How can homeowners apply this idea practically, maybe even in existing homes?
A really important question. So again, in America, we have a tendency to condition every cubic meter of space that we build, right? So and our houses have been getting bigger and bigger and bigger. So we'll have these large houses where the air conditioning is on in every room to the max. In case we're going to wander, from the dining room to the bedroom, to the kitchen, to the family room throughout the day, and we want it to be comfortable. And our houses are getting bigger. And America is one of the largest energy consumers per citizen in the world, so if not the largest. So this is a crisis that we have got to address. There's a couple of ways to address it that don't in any way diminish the quality of our life. One way to do that is to embrace advanced technology for setback thermostats. So if we're away at work, our house is set back, 10 degrees Fahrenheit or, 4 degrees Celsius, because we're not there. And set up in the summer. So we let it be a little warmer, and we just simply know we'll be home by 6. Let's make sure so one is to just take that big bubble and condition it, but condition it in a more discriminate fashion based on when we're going to be home. The other is to start to partition the bubble. And you can basically say, well, I'm never in the bedrooms during the daytime, because even if I'm working at home, we're going to be basically working in the following spaces. And there's half my house, if not 2/3 of my house, I can let those temperatures float. They can get cooler in the winter or warmer in the summer. So I can do zone controls in my house. What I would like to get people to consider is something that Sarah Suzanka wrote, The Not So Big House. Is it Sarah or Susan? I can't remember now. I'm going to get the two mixed up. One of them is a famous actress and one's a famous architect. But she wrote it, The Not So Big House. And she basically is trying to convince people to build 2,000 square foot or 200 square meter houses, not 6,000 square feet. She said, look, everything you need for a family of 4 or 5 is perfectly possible in 2,000 square feet. But you don't need to feel like you're in a little box. So you're learning how to, number one, make spaces feel bigger without making them physically bigger, but more critically, how to externalize some of the program. So your dining room, basically directly leads into an outdoor dining space, right? So you have a terrace that's connected. You have doors that open wide so that you're essentially getting twice. And we tend to entertain a lot more in the summer than we do in the winter anyway. So all of a sudden, the big table begins to make sense because it stretches straight from the indoors to the outdoors. You do a lot of those extended. You make what I call the living room balcony on apartment buildings. You don't make a balcony that's only big enough for a bicycle and a tiny little French cafe table. You make a balcony that's big enough for a couch and 2 chairs and a coffee table and everything you would have in a living room, so that you think about sitting outdoors as soon as the weather is even a little nice. As soon as there's a little breeze or a little sun, or you're extending your time outdoors from 2 months to 5-6 months. And we have a luxury here in Pittsburgh of having a house that's on an edge of a park, and we've built decks on the north and on the south and on the east. And we move around the decks based on whether we want to be wind protected and sunny, or we want to be in the breeze and in the shade. And we have tables in all those places and chairs, and it's a whole lifestyle. It's essentially externalized. At the commercial scale, we need to externalize as much program as we can. We don't need fire stairs to be heated and cooled. They should be outside the thermal envelope. We probably don't even need the elevator core to be heated and cooled, because by the time you get to the elevator, your coat is on, right? I mean, you've basically already transitioned to streetwear. So why would we condition those spaces? In Singapore, at a number of their universities, all the bathroom cores, the elevator cores, and the stairs are outside the conditioned envelope. And they have outdoor classrooms that almost match in size the indoor classrooms. They're just in very breezy, shady areas so that people can spill out and do lectures and lunch and all those things. So I think externalizing program is a really strategic activity for us. And zoning buildings. The one caution I have for Asia, as they migrate away from split heat pumps, as you know from looking at buildings in Asia, every window has got a heat pump, a split heat pump hanging off the edge of the window, piped into a fan coil in the bedroom and the living room. Every room has its own little, and it's very messy. When you look at the facades, you say, what a mess. They've got all these split heat pumps hanging all over the place. Well, the alternative is the American alternative, which is to put large heat pumps on the roof and essentially condition the whole building in one swoop to the same temperature universally. That would be a disaster environmentally, both for extending outdoor living and enjoying environmental surfing, but it also would be an energy disaster. So we really have to figure out how to zone our buildings and let mechanical systems only serve the rooms we're in for when we're in them, right?
And can we talk about why the standard indoors temperature in the US feels like winter in Europe? It's so cold.
Yes, we can. So the 22 Celsius or 72 Fahrenheit standard, and it's actually not just the US. I have to tell you that in Singapore, when I'm there, I travel with more layers than I do any other place, because it's like 18 Celsius is their standard indoor in the summer, right? And we're all dressed in summer clothing, freezing to death. Although there are examples of people trying to push that up. Ashley has already changed the standards, and they would like to have summer temperatures, 23 to 29 Celsius. I don't think there are any American building managers that would ever allow a 29. They might allow a 25. The reality is that we are dressed. If you can get a little airflow, we're dressed to be perfectly comfortable, certainly at 28, which is what the Japanese set as their indoor summer standard. I think we're stuck at 22 because there's a lot less. Again, this is sort of the lowest common denominator. 22 in winter clothes is a little warm, but it's palatable. 22 in summer clothes is definitely too cold, but if you put up enough layers, it's palatable. So I think the assumption is if we just set it at flat 22 year round, you'll have the least complaints. But energy-wise, it makes no sense for us to be picking a 22 annual temperature. We should be dropping it lower in the winter and higher in the summer. We should allow people to do task conditioning with little task heaters and task fans, and use a much broader thermal comfort band that was much more energy efficient and much healthier for us. There is a whole school of thought called alliesthesia. And the Australians have been doing a lot of research with this, just trying to understand how much does the human body need dynamics. If you're in a flat thermal environment, not to mention also a flat visual environment where you've got the same light level all year round, all day long, flat 22 Celsius, essentially still air all year round for 8 to 9 hours of work a day. We're really stuck in a rut. The question is, how much does the human body need the dynamics that nature provides? And a little bit like circadian light, I'm expecting the research to show that all of a sudden a lot of our hormonal responses are triggered by diversity of temperature, not by static temperature. And if we want to be healthy, we need diversity of temperature. So it all brings me back to the environmental surfing. Let nature rule for as long as it can, because it gives us diversity of light, diversity of airflow, diversity of temperature, diversity of sounds. I mean, there's so much that we get out of nature. And if we can just let it take over our buildings for at least some large proportion of the year, when it can, and then shift to high-tech solutions when it can.
I really liked the concept you explained earlier about kind of make it easy to go outside. I did an exchange semester when you talked about the universities in Singapore. I did an exchange semester in the amazingly beautiful building in Sao Paulo at FAO. And there we were also like indoors, outdoors, even though like the classrooms were like completely covered. We didn't have any windows. The light comes from the top. You still have energy because you have a lot of natural light. So Vivian, in your experience, what's the biggest lesson you've learned about designing healthier, low carbon buildings?
Oh, I think it's somewhere the marriage between the no tech or the low tech and the high tech. I think there is a role for advanced technology. Many of the things I've talked about, I mean, geo exchange and geothermal heat pumps, and those are high techs. Even good daylight and dynamic shading devices, some of those are high tech. But there is a huge number of low tech solutions and natural technology solutions and indigenous solutions that we need to embrace that really define the climate and culture we're in. I mean, I don't want to stay in a Hilton hotel in every city in the world that looks exactly the same. I want to stay in a Hilton in Singapore that's so different than the Hilton in Pittsburgh or in Zurich or in Barcelona. I want to be in the culture and the climate that I'm visiting. And I think there is something really exciting about getting the next generation of architects to embrace both the natural technologies and the advanced technologies to achieve net zero.
Like moving more towards biophilic design.
And that's a word we haven't yet talked about. And it may be really well known to your audience. Biophilia, was really put on the map by E.O. Wilson when he wrote a book called The Biophilic Hypothesis, and then with Stephen Kellert, who went on to write a series of books for architects on what does this mean. And now Terrapin Bright Green, who've published 14, actually just as of this month, 15 patterns of biophilic design, all of which you can download from the web. Amazing insights into what research is showing about humans' need to connect to nature. And this does go beyond the visual connection. We do need to see the seasons and the colors of trees and the dynamics of light, of daylight over time. But we also need to hear the sounds of nature, which includes human, by the way. Biophilia is not just plants and animals. It's a need for connection to living things, and we are part of that. So the ability to hear children at a playground playing or a tennis ball being hit back and forth on a tennis court, those are incredibly important acoustic cues. Birds singing, of course, and, crickets and, I have an app on my phone called Merlin where it'll literally you just say voice ID and it picks up all the bird sounds around you and tells you what birds they are so that you can begin to differentiate the sounds, which used to be very hard to do. You had to have an expert tell you, oh, that's a crow and that's a bluebird or that whatever it is, right? Now we've got an app from Cornell that tells us that exactly that. It turns out that biophilia is out exploring to what extent do we need the sensory dynamics of nature? Do we need to feel humidity? Do we need to feel the dryness? Do we need to feel the changes between a humid and a dry environment? When we pass a fountain and we feel evaporative cooling, to what extent is that important to the human well-being and health and performance? So it is a really rich field of study, and I think for architects, it makes such beautiful architecture. Pursuing biophilic design, I think, is a strategy to really creating beautiful buildings.
Talking about beautiful buildings, what's your favorite sustainable project in the world?
I think it would probably be a number of the eco resorts that have been built, in bucolic settings, whether it's Australia or Costa Rica or places where, if you can imagine hotels that from the minute you walk in, actually, I'll tell you my favorite one though, a hospital in Singapore. Actually, they built 3 biophilic hospitals in Singapore, and when you walk into the lobby of, it's called the KTPH, is short for a very long Chinese word, but anyway, when you walk into the lobby, it's an open air lobby, very high ceilings, lots of trees growing right there under canopy. It's shaded. There's a breeze. The information desk is in the open. This is a person or a group of people who sit behind a desk all day long answering questions outdoors. They're in the shade and they're in the breeze, but they are outdoors. And I asked them, I said, do you miss being in an air-conditioned lobby? Not at all. This is the most exciting, wonderful place to work. All of the food stands and where you go and buy, the pharmaceuticals and, gifts for your daughter who just had a baby, all of those are open air stands in this open air lobby. I mean, in shaded in the breeze. All the stairwells are open air, shaded in the breeze. All the escalators are outdoors. All the elevators are outdoors. The bathrooms are open air bathrooms. You just have a visual screen with a beautiful view of bamboo. You wash your hands you're looking out at, at a bamboo screen or the breeze. It's just beautiful. And it's only air conditioned in spaces that really need it. Now, again, Singapore is pretty ideal. It's warm and humid, but never super hot and humid, and it's never cold. So it's sort of, as long as you can get airflow, you've got a long environmental surfing story. The roof, they have reduced the mechanical system in that hospital to 1 roof out of 3 major hospital wings. And they've turned the other 2 roofs into community gardens. And there's an 80-year-old woman who runs the community gardens as a volunteer, and she has, 100 volunteers who come and work on these gardens. They have huge melons and fruits and legumes and salads, and they basically can feed everybody in the hospital 1 day a week off the roof of a building that normally would be occupied by mechanical plants that have been displaced by environmental surfing or biophilic design. And it's a beautiful rooftop. You get up there and you think you're, in a greenhouse, a nursery. They've been tracking the number of butterflies and insects and fish that they've been able to sort of renew. So it's a regenerative environment. Butterflies that hadn't been seen in Singapore, for 30 years are all of a sudden reappearing in this hospital complex because of the way it's designed. And So they keep track. They have photographs and they tell you about it. And they, every time someone finds a new one, it goes up it's amazing. So that would be the most inspiring, a hospital in Singapore, most inspiring biophilic environmental surfing project.
That's so inspiring. I wish every project was like that. Really, really cool. Thank you so much, Vivian. Now, if people want to follow your work and see what you do, where can they find you?
Well, I have to say I don't spend as much time building the website as I should, but I've been at Carnegie Mellon for well over 40 years. And so Carnegie Mellon website, School of Architecture would probably be the first place I would look. I do try, every time I do a webinar, I offer to make it completely open. So there should be webinars online that people can access. I think when I eventually retire, I'll start to upload as many papers and reports and case studies as I can, so they're available to anybody who wants them. I just recently went to the AIA Top 10 website, and the American Institute of Architects has given the Committee on the Environment, which is essentially one of the launchers for the LEED standard, COAT. They've been giving awards to the 10 best projects done by U.S. architects every year for the last 20 years. And I would suggest going to the AIA Code Top 10 website and reading those case studies of buildings. Now, they are U.S. architect-centric. They're not only in the U.S., because U.S. architects do projects around the world, but they would at least give you an insight into what's happening here. And they have 10, the Framework for Design Excellence, which was adopted by the American Institute of Architects. The year I sat on that board, they adopted a commitment to what the Committee on Environment felt were the 10 most important things that every building should do, including energy and water and mobility and health. And you can see how each of those projects excelled in trying to achieve those things. So there are lots of wonderful resources that I would recommend.
Thank you, Vivian, again for your time. It's been wonderful. Thank you.
Pleasure talking to you, and it's great. I love listening to some of the other podcasts, so I look forward to it.
A huge thank you for listening. Make sure you subscribe to the show wherever you listen to the podcast to support me and so you don't miss an episode. And while you're there, I'd also be so grateful if you could rate and review us. If you have any guest suggestions or any feedback, you can find me on the socials at Latina Schöpf. Thanks.